students, welcome back to another video of MATHIPHY. In today's video, we will do paper 6 of course code 0625, October-November 2024, variant 3. Question number 1 says a student investigates the cooling of water in different sized beaker. He uses the apparatus as shown in figure 1.1. Beaker A and B have graduations as shown in figure 1.1. So beaker A has the graduation with gap of 50 centimeter cube and beaker B has the graduation with gap of 100 centimeter cube. And here we have thermometer which will measure the temperature. Part A says record the room temperature theta R shown in the thermometer in figure 1.1. So in the thermometer the temperature is 21 and 22 degrees Celsius. B part says describe one technique used so that the temperature reading is as accurate as possible in the experiment. To get the most accurate reading from the thermometer, your eye should be at level to the scale where are you taking the reading to avoid any parallax error. So keep eye perpendicular to the scale while taking the reading to avoid parallax error. B part of the question says the student pours an estimate volume of 75 centimeter cube of hot water in beaker A. He uses the scale on the beaker as a guide. He puts the thermometer into the water in beaker A and records in table 1.1 the temperature theta at time t equals to 0. He records in table 1.1 the temperature of the water in beaker A every 30 seconds. The student repeats the procedure for beaker B as well. His readings are shown in table 1.1. Suggest one possible source of inaccuracy in the procedure even if it is carried out very carefully. Basically, the student takes beaker A and he pours 75 centimeter cube of hot water into the beaker and records the reading initial temperature of the beaker at time t equals to 0. After it, he will let the water to cool down and he will record the temperature after every 30 seconds from the beaker to study the cooling rate. And he will do exactly the same for beaker B. Now, one possible source of inaccuracy in our experiment could be because we are pouring 75 centimeter cube and our beaker is graduated with the gap of 50 centimeter cube. So it is difficult to measure exact 75 centimeter cube of volume. You can also write that if the student takes longer time to record the temperature, it will affect the time interval of 30 seconds that he has already set. So this is table 1.1 and this is initial temperature of beaker A which is 82.5 and beaker B is at 80 degree initially. And after 180 seconds, the final temperature of beaker A is this and beaker B is this. Now C part says write a conclusion describing the effect of changing the size of the beaker on the rate of cooling of the water. Justify your answer by reference to the values from the table. You can clearly see that beaker A is initially at 82.5 degrees Celsius and after 180 seconds it is at 73 degrees Celsius. That means the change in temperature is 9.5. And for beaker B, the change in temperature is 16.5 degrees Celsius. Now we will calculate the percentage difference between the values to see if they are close or not. If the percentage difference between these two values is less than 10%, that means these values are equal. But if the percentage difference between these two values is greater than 10%, that means these values are not close and don't lie within the experimental accuracy. How can we calculate the percentage difference? Formula is V2 minus V1 over V2 plus V1 divided by 2 multiplied by 100%. Let me put the values. Value 2 is 16.5, value 1 is 9.5. Then 16.5 plus 9.5 divided by 2 multiplied by 100%. So these values are within 53% of difference with each other. That is very great. That means these values are not close. So yes, the size of the beaker is affecting the rate of the cooling of water. D part says the student in other school do the same experiment using the identical apparatus. State one variable they need to control in order to obtain reading as close as possible to the reading in table 1.1. So the students are doing the same experiment and they're using the identical apparatus. So how can they make the readings close to the table 1.1 if they also make the surroundings identical? So answer is environmental conditions should also be identical. For example, temperature and other things. E part says calculate the average cooling rate X for beaker B. Use the readings for beaker B in table 1.1 and the equation that is given. The T is 180 seconds, theta naught and theta 180 are the temperatures of beaker B at T equals to 0 and T equals to 180 seconds. Include the units of the cooling rate. So let me substitute the values. Theta naught is the temperature at time equals to 0. So this is 80 and theta 180 is the temperature at 180 seconds. So it is 63.5 for beaker B and the time interval between these two is 180 seconds. Now doing this calculation, I will get the rate of cooling which is 0.0917. Now coming to units, in the numerator it is degree Celsius and denominator it is seconds, so it is degree Celsius per second. F part says another student think that more thermal energy is lost from the surface of the water in beaker B than from the sides of the beaker B. Suggest an additional experiment that she can do with beaker B to test her idea. Beaker B is this bigger beaker, and she is saying that more energy is being lost from the surface of the beaker rather than from the sides of the beaker. Now, how can we test if it's correct? We will cover the beaker with lid and we will compare the energy loss with lid and without the lid to test her idea. So the answer is that we will cover the beaker B with lid and compare the energy loss without and with the lid. Second part says suggest how the cooling rate of water in beaker B in this additional experiment compare with the value of X in E part if her idea is correct. So in E part the cooling rate that was X was equals to 0.0917 degree per Celsius. And now we are covering the beaker with lid. So will this lid affect the cooling rate? Yes, it will affect it. By covering the beaker with the lid, energy loss from the surface is reduced. That's why the cooling rate will be less than X. Question number 2 says a student determines the resistance of a resistor. She uses the apparatus shown in 2.1. So here we have the apparatus. This dark line is the wire and this is a resistor and a crocodile clip attached with the wire to vary the resistance of the wire. You know resistance is directly proportional to length. So if you vary the length of the wire using this clip, if the length increases, the resistance of the resistor also increases. A part says on figure 2.1 draw a voltmeter connected to measure the potential difference across the resistor. We connect a voltmeter in parallel with resistor to measure the potential difference. B part says the student connects the crocodile clip to the resistance wire at 100 centimeter mark on the meter ruler and measure the potential difference V0 across the resistor. The voltmeter is showing the reading and this is the reading. Record the value of V0 shown on the voltmeter in figure 2.2. So the reading is 3.2 volts. I'm writing it over here, 3.2 volts. In C part, we are going to measure the current in the circuit when the length is 20 centimeter. To measure the current, we need to first figure out what is the value of each small division. To get this, I will divide 0.2 with the numbers of division inside it, which is 10. So each small division is 0.02. and the needle has moved 9 divisions while to 0.02 times 9. So the current is 0.18 amperes. D part says the student measures the current for the length of the resistance wire 30 cm, 40 cm, 50 cm and 60 cm. Her readings are shown in table 2.1, but the current for 20 centimeter length is missing that we have just calculated above, which is 0.18 amperes. Plot a graph of L centimeter at y-axis and current at x-axis. Draw the best fit straight line. You do not need to start the axis at 0 origin. So on y-axis we are supposed to put the length of the wire, and on x-axis we are supposed to put the current, and we are supposed to draw this table on this graph. I have selected a suitable scale for my readings to put on the graph. On y-axis, one small box is representing 1 centimeter. On x-axis, one small box is representing 0.01 amperes. Now I am putting the values of table in the graph. After substituting the values, I will draw the line which best fit my entered data. So I think this is the line which is best suitable for my data. Now part number 1 is saying determine the gradient of the graph. Show clearly on the graph how you obtain your necessary information. So to get the gradient, I will mark 2 random points on the graph and note the coordinates of that points. For this point, it is 0.3 and 40. And for this point, the coordinates are 0.4 and 55. I am naming one coordinates as x1, y1 and other as x2, y2. And you know the formula to calculate the gradient is y2 minus y1 over x2 minus x1. Now I will put the values in this formula. Y2 is 55, Y1 is 40, X2 is 0.4 and X1 is 0.3. Doing all these calculations, my slope or gradient would be 150. I am putting the value of the gradient in the space provided. G is 150. Now second part of the question is saying calculate the resistance of resistor. Use the value V0 from part B and the equation that is given where K is 1 ampere. The V0 in part B that we calculated was 3.2 volts. So I am putting the values. G is 150, V0 was 3.2 over 100 and the value of K is 1.0. Doing the calculation, the resistance will turn out to be 4.8 ohms. F part of the question says, suggest one practical reason why other student might not obtain the same results as the student even if they do the experiment carefully. There are some other students who are using the same kind of apparatus but they are not getting the same values. What could be the reason? The reason could be that the wire that they are using may have uneven thickness or the clip is not properly attached with the wire. So the answer is the wire they are using has non-uniform diameter or it is damaged. You can also write that the crocodile clip is not properly attached with the wire. Question number 3 says a student investigates the refraction of light by transparent block. He determines a quantity known as refractive index of the material of the block. The student's tray race sheet is full size in 3.1 figure. A part says the student places a transparent block ABCD near the center of ray trace sheet as indicated in figure. Draw a normal N extended above AB, label the upper end of the normal with letter L, and extend the normal downward until it crosses the line CD. Label the point at which it crosses CD as F. So firstly, we have to draw a normal at point N. For this, I will align my protector with line AB and will draw an angle of 90 degree from the line AB. This is the normal and I am naming it L. After it, the question is saying to extend the normal to the line DC, and wherever it cuts the line DC, I have to name that point as F. So I've done this. Now, second question says the student draws the line EN as shown in figure 3.1. On figure 3.1, measure the acute angle theta 1 between LN and EN. Now we are going to measure the angle between LN and EN. I'll place my protector like this, align it with line AB, and I will measure the angle from 0 degree, and this angle is nearly 74.2. To get the remaining angle from the normal, I will subtract 74.2 from 90 degree, and I'll get my angle from the line LN, and this angle is 15.8 or nearly equals to 16 degree. So I am writing that theta 1 is 16 degree. Now B part is saying the student places two pins P1 and P2 on the line EN. Measure the distance D between P1 and P2. So we have to measure the distance between P1 and P2 by using a ruler, and this distance seems to be 3.5 centimeter, and it is not a correct distance because the distance between two pins should be at least 5 centimeter. Now going back to the question, the distance is 3.5 centimeter. Now, second part of the question is saying suggest whether the two pins are suitable distance apart for the accurate ray tracing and explain your answer. So I will write no, they are not at suitable distance because the minimum distance between two pins P1 and P should be 5 centimeters. C part says the student views the image P1 and P2 through the block. He places the pins P3 and P4 as the pin P3 and P4 and the image P1 and P2 all appear exactly one behind the other. Draw a suitable line through P3 and P4. Extend this line to cross NF. Label the point at which the line meets NF with letter G, and label the point at which the line crosses CD with letter H. Join H and N with a straight line. The question is saying measure the length A of the line HN and measure the length B of the line HG. So I will make a line joining P3 and P4 until it cuts the line NF. From the point where it cuts the line NF, this point is G, and the point where it is cutting DC, this point is H. Now I will join H and N, and I will measure the length between N and H first, which is length A given by the question, and this length is 6.1. So NH length or length A is 6.1 centimeter, and GH length is nearly 4.2 centimeter, which is length B. So I am writing length A is 6.1 centimeter, length B is 4.2 centimeter. Second part says calculate the value of N for the refractive index using the equation A over B. So A is 6.1 and B is 4.2. Dividing them both, I will get refractive index, which is 1.5. E part says the student repeat the above procedure for an angle theta 40. He places two pins P5 and P6 so that the pins P5 and P6 and the image of P1 and P2 all appear exactly behind each other. Draw a line through P5 and P6 until it meets GH. Label the point at which the line meets GH with K, and label the point where the line meets CD with letter R. Measure the angle alpha, where alpha is acute angle between RK and GH. Okay, so now I will make the line joining P5 and P6 until it cuts the line GH. The point it is cutting the GH line, it is named as K, and the point where it is cutting DC is named as R. Now I will measure the angle GR and KH. putting the protector over here, aligning it with the first line, and the angle is nearly equals to 23.4, which is approximately equals to 24. So I am writing the angle as 24 degree. Second part says, another student suggests that angle alpha should be equal to difference between the angle theta 2 from E part 1 and angle theta 1 from A part 2. State whether your results support this suggestion. Justify your answer by reference to the values from your results. We have to prove that this theta 2, which is 40, and this theta 1, which is 16, their difference should be equal to alpha, which is 24. So I'm doing the difference 40 minus 16, which is equals to 24, and it is exactly equal to alpha value that we have. So we have proved it. Now I'll write yes, alpha is equals to the difference between theta 2 and theta 1, and the justification is given in form of equation, values are close and within the experimental accuracy. F part says suggest one technique to use in this type of experiment to ensure that the results are accurate. So we can make the lines as thin as possible and place the pins vertically straight to avoid any kinds of confusion. Question number 4 says a student investigates the speed of a small trolley moving down to a sloping ramp. Plan an experiment which all will enable her to compare the effect of different angles of slope on the average speed of the trolley between the points on the ramp. Average speed can be calculated by this equation. Speed is equals to distance over time. The apparatus available is a long ramp with the support that enable it to be set on different angles and the small trolley. In your plan, list any additional apparatus that you need. Firstly, we have the equation distance over time. To measure the time, we need a stopwatch. So I am writing first apparatus is stopwatch. After it, we have to measure the distance as well. To measure the distance, we need a ruler as well, or you can write meter ruler. And thirdly, we need to measure the angles of the slope, so we need a protector as well. Now next, it is saying explain briefly how to do the experiment, including how to take the measurements so that the average speed can be determined. Basically, our experiment is to set the ramp at different angles of slope and then to leave the trolley fall vertically down, and we will measure the distance traveled by the trolley and the time, and we will calculate the speed out of it, and we will see how the speed varies with the slope. So firstly, we will set different angles of slope 20, 30, 40 and release the trolley from the fixed point. Then we will measure the distance traveled by the trolley and time taken by the trolley in each slope angle. And we will calculate the speed by the equation speed is equals to distance divided by time. After it, we will compare the slope angle and the speed of the trolley. Next, the question is saying suggest a possible source of inaccuracy even if the method is carried out very carefully. So the trolley has to fall very quickly from the top and the time interval is very small and it is very difficult to measure this with the stopwatch. So the source of inaccuracy is the time taken by the trolley is so small that it would be difficult to measure. Then the question is saying state the key variable that you're going to keep constant. So constant variable are the starting point of the trolley which is fixed, and you can also fix the ending points of the trolley where it is going to stop. Then it is saying draw a table with column heading to show how to display the readings, and you are not required to enter any reading in the table. So this is the table we are going to draw. In the first column we are going to write angle, then distance, time, and then we calculate speed from distance and time. After it, to go to conclusions, we will draw conclusions by drawing a graph between the slope of the ramp and the speed of the trolley to compare the results. Thanks for watching the video. If it was helpful, please hit the like button and subscribe my channel.